Welcome back. In this lecture, we are going to understand about what type of use cases we are going to implement using provisioners and how many types of provisioners are there in Terraform, and also what are these provisioners and then why we will use it. Okay, so provisioners can be used to model specific actions on the local mission or on a remote mission in order to prepare the servers. In simple terms, we can pass data into virtual machines and other compute resources which Terraform is creating as part of resource creation. Okay, so we can also run configuration management software like Packer, Chef, and then Ansible after that respective resource is created. Example, EC2 instance or Azure VM instance or whatever it is. Okay, and provisioners should be used as a last resort at any point of time. So we need to first check whether there is any first class Terraform provider functionality. If that is available, then we should go ahead and then use it. Okay, and from provisioners perspective, we'll have creation time provisioners and then destroy time provisioners. So creation time provisioners are nothing but when the resource is getting created, at that point of time, these respective provisioners will be kicked in once the resource is created. In the same way, destroy time provisioners will be kicked in during the resource destroy time. So that's about the types of provisioners during creation and then destroy time. So for these provisioners, there will be a failure behavior of continue or fail. Okay, so if your respective provisioner fails, if you want to continue, so then you can use the continue tag in your provisioner code so that it will ignore the error and continue with the continue with the creation of the resource or destructing the resource. In the same way, the default behavior is if you don't provide the continue tag, default behavior is fail. So it will raise an error and stop applying the changes. If creation time provisioner, then it will even taint the resource. Okay, so there are three types of provisioners available. So those are nothing but file provisioner, remote-exec provisioner, and then local-exec provisioner. So let's see what are those things now, right? So before going into understanding about these provisioners, we also need to understand about something called connection block. Okay, so most provisioners require access to the remote resource via SSH or WinRM connections and expect a nested connection block with details about how to connect. Okay, so if you want to connect to SSH or WinRM, means like Windows machines using WinRM, so in your respective resource, whatever you have created where you are planning to use the provisioners, so you need to define a connection block. Okay, so connection block looks like this. Okay, connection and the type of connection and host name of your respective resource and username with which you are going to connect and then that respective private key. Okay, so now for the host name, you see here we are using the self.public IP. Okay, so ideally you will use AWS underscore instance dot local name of that instance dot whatever the public underscore IP, but here you are using self.public IP. So because expressions in connection blocks cannot refer to their parent resource by name. Okay, so if you define this connection block on the EC2 instance resource, then you need to use the self.public IP. Okay, so you need to use the self object for that. Okay, but if you are defining this connection block in null resource, at that point of time, the AWS instance dot local name dot public IP can be used. So we'll see what is null resource in the upcoming slides. Okay, so let's start with the file provisioner. Okay, so file provisioner is used to copy files or directories from the mission executing Terraform to the newly created resource. Okay, it might be EC2 instance or whatever it is. Okay, and the file provisioner supports both SSH and WinRM type of connections. Okay, so this is the EC2 instance resource, right? And inside that only we have the connection block which we discussed, and here you can find the file provisioners. Okay, so provisioner, file, and then source from which in your local mission, and in destination to which location in the destination you want to copy the file. Okay, so you can copy a independent file or you can copy a text into a file and then create that in the remote mission, or you can copy entire folder. So different options are available in the file provisioner, which we will discuss detail and then implement in the practical example. Okay, in the same line, let's move on to the next provisioner, which is called local-exec provisioner. So the local-exec provisioner invokes a local executable script after a resource is created. So using Terraform, when you run the Terraform apply, if a EC2 instance is created in the AWS cloud, after that using local-exec provisioner, you can run some scripts directly in your local machine where you are running the Terraform. Okay, so this invokes a process on the machine running Terraform and not on the resource in the AWS cloud. Okay, so this is an example of the local-exec provisioner. So using local-exec provisioner, you have brought the IP of your AWS instance and then stored in creation time private IP.txt. Okay, and you are storing that in your local desktop where you are running the Terraform commands inside a folder local-exec output files. Okay, so this is a creation time provisioner for local-exec provisioner. Okay, in the same way, you will also do a destroy time provisioner. For destroy time provisioner, you are giving the tag as when is equal to destroy. Okay, default any provisioner you define, it is going to be creation time. So you will define when it is equal to destroy. At that time, this provisioner will kick in only during the destroy time of the resource. So whenever you run the Terraform destroy, so this provisioner will note the time of that respective instance when it is destroying and then save it in destroy time.txt inside your local-exec output files on your Terraform working directory. Okay, so this is about the local-exec provisioner. In the same line, you will have remote-exec provisioner. So the remote-exec provisioner invokes a script or a command on a remote resource after it is created. So which means like using Terraform apply, whenever you run and then an EC2 instance is created, after creating that EC2 instance, inside that the script is going to run. So this can be used to run a configuration management tool or bootstrapping into a cluster or many more examples. Okay, so if you see here in our example, first we will run the file provisioner, so which will copy a file named filecopy.html to temp directory in your remote resource. Okay, which is nothing but remote EC2 instance. And then you will call the remote-exec provisioner and then you will wait for 120 seconds and then copy that temp filecopy.html to /var3w.html, which is nothing but web server's root directory, and then using browser you are going to access this filecopy.html. So this one you are going to go ahead and then practically implement when you are doing the remote-exec provisioner. Moving on, so you will also understand about a null resource and null resource in combination with these provisioners. Okay, so if you need to run provisioners that aren't directly associated with a specific resource, you can associate them with a null resource. So there are situations where you really don't want to run the provisioners with a regular EC2 instance resources or anything. Okay, because if you make a change, then that respective EC2 instance resource also needs a change, right, with this provisioner. So in those cases, what you will do is you will create a null resource and inside this null resource you will run your provisioners. Okay, so instances of null resources are treated like normal resources, but they don't do anything. Okay, same as other resource, you can configure provisioners, connection details on a null resource. With that said, so this is the entire implementation we are going to do in the null resource, which is nothing but after the EC2 instance is created, you will create a time sleep resource which will wait for 90 seconds because it need to, once the resource is created, it also need to wait for the web server to be installed on that. Okay, which we will be calling using EC2 instance user data. So for that purpose, we will give a wait time of 90 seconds. And once this is done, you will go to null resource and inside null resource, you will say depends on this respective resource, which means once the EC2 instance is created, so it will wait for 90 seconds. And once this time sleep resource is completed, then the depends on meta argument will trigger and then it will move on to this triggers option. Okay, what the triggers option does is it has a tag called always update and then timestamp. Okay, so which means every time Terraform apply is run, so this resource will have an update. Okay, means like this resource will have an update. That's the trigger you have implemented. So every time Terraform apply you run, so the timestamp will be changed which means this resource will have an update, which means whatever the statements you are going to define after these triggers under that, okay, any provisioners or anything, all those will be re-executed for every Terraform apply. So this type of use cases will be helpful for deploying any continuously updated static content on web servers. Okay, so now we'll implement the connection block after these triggers, and then we'll copy the apps app1 directory to temp using file provisioner, and with remote-exec provisioner you are going to copy that app1 directory to the var3w HTML of your web server. So now if you go back and change anything in your index.html or anything, or if you don't change anything also, or if you add additional files in your app1 folder in your local also in apps app1, so whenever you run Terraform apply, latest changes, entire this respective null resource will be triggered, and then all the commands will be triggered, and then app1 will be freshly copied to your static web server, whatever you have created. Okay, so that's the use case you are going to implement as part of null resource. Okay, and these are the means, like for the file provisioner also we have the practical examples, and then in file provisioner you have Terraform manifest, in remote-exec you have Terraform manifest, in local-exec you have Terraform manifest folder, and also in null resource also you have the Terraform manifest, and you have the GitHub step-by-step documentation for all the 4 things whatever you are going to implement. Okay, in the same line, all this is going to take close to 1 hour 8 minutes to complete the entire thing. Okay, so I'll see you in the next lecture with file provisioner practical implementation. Until then, bye bye. Thank you.